Okay, good morning, folks. Thank you for making it here through the Bangalore traffic. You all are the real heroes. Hope you all have had some good coffee today. I'm Chaitanya. I work as a staff engineer at Razorpay. And today I'm here to talk about AI, UI, DS, Figma to code. That's a lot of jargon. I don't know who wrote that title. ChatGPT did. But anyway, let's try to untangle it. First up, what's a design system? It's basically a collection of reusable components, patterns, guidelines that help teams build high quality user interfaces efficiently. To sum up, build good, build fast. So at Razorpay, we built our own design system called Blade. Blade helped us achieve consistent look and feel across all of our products. It made sure that we can reuse a lot of the components and a lot of our code, and whatever we built was completely accessible right out of the box. And we were very happy with what we achieved. We were very happy with the kind of pace that Blade got us, the kind of quality that Blade got us, and our teams were building really high quality products really fast. Also, be sure to check out Saurav's workshop tomorrow on design system. I'm not going to dive too deep into it since he has this covered. With our design system, we saw a 3x boost in productivity for designers and developers. In fact, in some areas, we saw a boost that was much higher than this. And we were extremely happy with this boost. And we built some tooling around it to make it even more happier. And that's when the AI boom hit us. And everybody started asking us questions like, why don't we use Lovable? Why don't we use Replit? Why do we need a design system? AI can do it better than us, faster than us. And we started asking ourselves that, what can AI do for us? And for the longest time, all we could hear was AI, AI, AI. We could think about AI, AI, AI. So we thought, let's do our research. Let's understand what AI can do, what AI can't do. So we realized that AI knows a lot. It definitely knows React. It knows TypeScript. So naturally, we asked AI to build a UI for us. And it did a decent job. It built some good-looking code, semantic code, but the output of the UI looked like I can go book a train ticket on it. So we thought, this is, it's all right. It can generate UI code really, really fast, and it's really good at it. But what it's not good at is generating good UI code really, really fast. And now I know this is very arguable, very debatable, because what's good for one use case may not be good for some other use case. So we thought, what's good for us at Razorpay? And how do we define good UI code at Razorpay? So this is what we ended up with. It needs to be consistent, it needs to be reusable, it needs to be accessible. And this sounded awfully similar to a problem that we were already trying to solve with our design system. And we realized that design system and AI was a match made in heaven, like Romeo and Juliet minus the tragic ending. So design system will take care of doing things good, and AI will take care of doing things really, really fast. So we just asked AI to use our design system, and it actually did a decent job because Blade is already open source, so it knows a little bit about Blade. It tried to do something, but it failed spectacularly. It was completely riddled with errors. Even though we tried to fix it, it didn't really work out. So we wondered, why did it fail? Our AI buddy knows a lot of stuff, but what it doesn't know is about our design system. It has very little knowledge about it. So we realized that we can't just say, hey, go ahead and build a login page. We need to give it a lot more information, a lot more context for it to meaningfully build a login page that's built with our design system. So we need to tell it to use specific set of components. We need to give it documentation for those components. We need to give it examples for all of those components and how to use them. We also need to give it instructions on what our coding practices are so it can code better. So what we ended up with was a very detailed prompt, and it was quite nicely structured. We had a task where, the task is to generate a login page. We had nice guidelines on what the login page should look like, and how it should use our Blades components. And we also had a lot of context, which components to use, how to use those components, some examples of those components. But we realized that writing such a detailed prompt every single time is so exhausting. Some would even argue that I could write my code faster than writing such a prompt. And writing such a prompt every single time is just too tiring. I was sure I'm at least not going to do it. So what would an ideal dream prompt for us look like? What would make my life easier on a day-to-day basis? What if I could just say this to AI? Build with a link to my Figma design. What this meant is that I could leverage the expertise of our existing design team. Our design team never has to leave their Figma files. They can completely still build on Figma. And we don't have to rely on AI's creativity for design. We know our design team is good and they can design better than a lot of AIs out there. So let's just rely on them. We don't have to write very detailed prompts for AI. We can just give us a small, simple prompt. And we can keep our focus on figuring out a very strong business logic for our product. But this sounds too good to be true, right? This doesn't seem like it's achievable or just doesn't seem real. Let's actually look at it in action. So here I have a login page, and this is on my Figma. It has a hero content on the left and a floating card on the right with some components for login within it. I'm going to copy the link to this UI design from Figma. I've opened up Cursor, which is the IDE that we use on a day-to-day basis. And Cursor has an AI right in there, and I'm going to ask it to just build and give it the Figma link. Now it's going to do a bunch of stuff that we are going to ignore for now. We'll get into the details of it later. At the end, it's generated some code, and if you see the code here, all of that is coming from our design system. I'm just going to accept this code and see the output. This looks exactly like the design that we started off with. So all we had to do was give the link to design, and AI took care of the rest of it. But this still looks like some black magic, right? So how does it actually work? So first, we have our IDE, which is Cursor. Cursor talks to Blade's MCP server, and Blade's MCP server talks to Blade's AI server. Quite confusing. Let's probably dive deeper into smaller pieces, right? First up, we have Blade's MCP server. To understand what Blade's MCP server does, we need to understand what Model Context Protocol is. It's a standard protocol for AI models to connect to different data sources and tools. Think of it like a USB-C port for AI. It makes connecting to tools and data simple and universal. It works on a client-server setup where you have MCP clients like Cursor or Claude Desktop, which connect to MCP servers like Blade MCP, which provide specific features and tools. This is written by ChatGPT, so it's still a bit confusing. I don't know what that really means. So how I really understood is that if you have Alexa at home and you ask Alexa, hey Alexa, play Uptown Funk by Bruno Mars, hopefully Alexa is not going to sing the song. It's going to connect to a service like Spotify and ask Spotify to sing it for us. If I ask Alexa what the time is, it doesn't need to connect anywhere. It already inherently knows what the time is. So it's just going to tell us that. If I ask Alexa to brief me on today's news, it's going to connect to a service provider like CNN and get today's news and tell me what it is. So this connection part that Alexa does, where it figures out what to connect to and how to connect to, is what MCP is trying to solve for AI. So instead of Alexa, imagine we have Cursor here, and we ask Cursor to build a login page with Blade. Now Cursor has no idea what Blade is. So it's going to reach out to Blade's MCP server to understand how to build this login page. If I ask Cursor what a promise is in JavaScript, it doesn't need to go anywhere. It already inherently knows JavaScript. So it's just going to tell me what a promise is. If I ask Cursor how to disable a specific Blade button, it knows it needs to go back to Blade's MCP. If I give it our dream prompt to build with a Figma link, it knows again it needs to go to Blade's MCP to do this. And similarly, Cursor can connect to multiple MCP servers, not just Blade. So Blade's MCP server has some specific responsibilities. It needs to help Cursor understand how to use specific components, and it needs to help Cursor convert just a Figma link directly into UI code that's written with our design system. To solve these specific responsibilities, we built two separate tools. One was get Blade component docs and one was get Figma to code. So the first tool, it's pretty simple. What it does is it accepts an input of list of component names like button, text input, and it gives an output with the detailed documentation for each of these components. So let's see how this actually works in action. So here I have my cursor opened up. I'm going to select a button component here, and I'm going to ask cursor, how do I disable this button? Now cursor doesn't know how to actually disable it. So it's going to reach out to Blade's MCP server and make a tool called to get Blade component docs. We're going to run that tool. It's figured out that the right prop is disabled. It's applied that already to the code. And if I open up the MCP call, you can see the input is the component name, that's button. And the output is the entire documentation of button, which cursor has now used as context to figure out how to disable this button. Similarly, for get Figma to code, it will also have an input. In this case, it will be the actual Figma URL. What's important in this Figma URL is the file key and the node ID. Cursor will smartly figure out what the file key and the node ID is and just use that as input. And the output is somehow magically the UI code that is written with React and Blade. So let's look at the example that we saw earlier, but let's slow it down a little and see what cursor is actually doing. So just like earlier, I'm selecting the link to this. I'm asking cursor to build using this Figma link. Now it's trying to figure out what to do. It realized that this needs Blade. So it's making an MCP tool called to Blade's get Figma to code tool. Input is Figma's file key and node ID. And somehow magically the output is the actual code of the UI. So even though it actually has the code to the UI, cursor realized that I need a little more information. So it made another tool call to get Blade component docs with all the components that it needs for more information. It's got the documentation back. Now it's trying to figure out where should I place this code. It figured out there is a loginpage.tsx file. It's trying to place the code there. Oops. It realized there is some error in the card component. Because it has the documentation, it's going to try and fix it. It has fixed it. It's put the code in the right place. It's let us know what it has done. And just like earlier, we've accepted the code. And the output is exactly like the Figma file. So all the developer had to do was paste the Figma link and cursor took care of the rest of it. But it's still a black box, right? How did that tool call happen? How did a Figma URL translate itself into actual UI code that looks like this? So let's dive a little deeper into that. So what happens is when cursor calls get Figma to code tool with the file key and node ID, it reaches Blade's MCP server. Blade's MCP server simply just forwards it to Blade's AI server with an API call, and it sends the file key and node ID. Now this is where all the magic happens. This is where the Blade's AI server will figure out how to talk to Figma and OpenAI to actually convert that URL into code. So first up, what we are going to do is we are going to talk to Figma and collect as much context on the design as possible. And that context will help LLM generate better code. So because we know the exact link to the Figma file, we're going to ask Figma to give us a screenshot of the design. And what I'm going to do is maintain a context store where every context I collect, I'm just going to dump it here. So the first thing that we've collected is the screenshot of the design. We've put it in our context store. Next, what we are going to get from Figma is the JSON representation of the Figma design. So just like every web UI has an underlying HTML representation, every Figma design has an underlying JSON representation. So I'm going to fetch that from Figma. But it's a lot of jargon. Even if you see it in the first go, you're not going to understand it. Definitely LLM is not going to understand it. There is a lot of stuff there that's not needed. So this is where we did a lot of smart transformation and translation, where we converted this JSON dump into something that is a little more meaningful for an LLM to understand. It's still a JSON file, but it is a little more structured. It has the component name, in this case, text input, and properties of the component like value, suffix, prefix, placeholder, etc. And this we are going to do for the entire design. And we're going to put this JSON representation of the design in our context as well. Now, because we have the JSON representation of the design and we know the components that are used inside this JSON representation, we can figure out the list of all the components that are used in this design. Now that I know all the list of components that are used in the design, I'm going to use that to fetch the documentation for all of these components and put that in the context store as well. Finally, it's time to talk to our LLM. Let's get some more context. I'm going to ask an LLM to take the design screenshot that we got from Figma and ask it to describe it in detail. We're going to ask it to tell us the hierarchy and grouping of different components, the positioning of different components, alignment, spacing between the components, any colors that it sees, and any text content that's on the design. And we're going to take this description of the UI and we're going to store it in our context again. Whew, okay, I think we have enough context now. With all this context, now what we're going to do is actually build a prompt and tell AI what to do with all of this context. So we're going to create a system prompt which is neatly structured. It has a task, it has some guidelines, it has some context. So task is going to be a very straightforward task that generate a UI code using the screenshot and the detailed description with React, TypeScript, and Blade. We're going to give it a lot of guidelines so it understands what it needs to do really, really well. We're going to tell it how to use the documentation to figure out the usage of the components and props from our design system. We're going to tell it where to import the components, utilities, and icons from. We're going to tell it how to use Blade's box component to create responsive layouts. Give it some examples for those layouts as well. And we're going to teach it how to actually use the JSON representation of Figma to convert that into a React component, how to do the prop mapping, and give a few examples of the same. And finally, we give it some output requirements, what kind of output we want, how do you want it to be structured. And the more detailed these guidelines are, the better your outcome will be. We had to tweak our guidelines a lot so that AI could really understand what needs to be done. And finally, all the context that we collected, we're going to attach it to the prompt as well. So AI can use all of this information to actually create code. Now we invoke an LLM with this entire system prompt, and this is where it will actually convert a single Figma URL to actual React code that is built with our design system. So just to recap, this is how the flow looks like. Blade AI server will reach out to Figma and get as much design context as possible. Is going to reach out to OpenAI and with the design and component context and a bunch of instructions and ask it to convert it to code. It's going to give us back the UI code that is written with our design system. And all of this is abstracted into two simple tool calls for Cursor. Cursor doesn't have to understand what's happening behind the scene. The developer definitely doesn't need to understand what's happening behind the scene. All they have to care about is whether these tool calls are getting called or not. And when we made these tool calls, we realized that there is a need for a lot more. So we didn't just stop here. We created a tool that helps you get started with Blade. We created a tool that helps create cursor rules so that cursor understands Blade better. We created a tool that understands Blade in general, how to do theming with Blade, how to install dependencies of Blade, how to figure out what the changelog is of Blade. We created a tool that not only understands the components, but the design patterns of Blade. So think of form groups, creation views, list views, all of that is available with our tool call. We realized that it's not just engineers who are using our MCP, but also non-engineering teams who want to get started with vibe coding. So we created a tool that creates a new Blade project from scratch so that they can build new products really fast. And the best part is that all of this is available in the open source. So you can go to Blade's repository, check out all of these tool calls, see what we've done, help us fix some bugs if there are any. So the real magic happens when we use all of these tool calls together to create something beautiful. Just a few days back, Saurabh from our team recorded a demo of all of these tool calls working together. So let's see what happens when all these tool calls work in tandem. So I've opened up Cursor and I'm going to ask Cursor to create a simple dashboard using Blade, of course. So it's making an MCP tool call to create a new Blade project since this is completely empty. It's scaffolded a new project. It's adding cursor rules. It's installing dependencies. Awesome. Now that it knows that this is a simple dashboard, a dashboard is going to need navigation. It's going to need a top navigation and side navigation. That's the pattern at Razorpay. So it's fetching documentation for these components, and it's figuring out how to place this and where to place these. Great. Now it's figuring out how to actually run the project. It's given us a command to run it. And we have an actual working dashboard with navigation in place. But the main content area is completely empty. We need to fill it with something more meaningful. So let's actually go to Figma and pick a real design that one of our designers have created. Let's copy a link to it and ask cursor to put this design in the main content area. It figured out that it needs to make a tool called to get Figma to code. And just like that, we have the entire code for the design. It's trying to place it in the right places. And if you look at the output, it's ready. The design is created in our UI. Let's add a heading on top of there. Let's add a heading to the main content area. It figured out that it needs to be a blade heading. But if you see the button, when I click on the add additional website button, it's doing nothing. It needs to do something. So what we're going to do is we're going to ask cursor to actually do something on the on click of that button. So we want to create an entire creation flow of addition of new website on click of that button. We want a stepped form for it. So we're just going to ask cursor to do that. Cursor has figured out that this needs a pattern. It's not going to be able to do it on its own. So it's figured out that it needs a form group pattern and a creation flow pattern. So it's figuring out the right documentation for this. It's got the documentation. Now it's going to contextualize into the website addition flow and use those patterns to create a website addition flow. Let's let it do its magic. It's letting us know what it has done. And now if I click on add additional website, it has actually created the entire add additional website flow, which is exactly the pattern we follow at Razorpay. And it's not just a UI, it's a functional UI. It has validations in place. So within minutes, we were able to not just scaffold a dashboard, but create an entire flow that's following Razorpay's brand language, Razorpay's design language, and it's built with our design system. So this is actually how we've changed how people use design system at Razorpay. We've not just leveraged AI to build the design system, but changed how our engineers interact with our design system. Nobody needs to go to our documentation and figure out anything. They just need to talk to cursor and tell it what needs to be done. And we also enabled a lot of non-engineering people like product managers to use these MCP tools with Claude Desktop and actually build real actual products that we can take to production because it's built with our design system and our design language. The entire journey was definitely full of a lot of pivots and experimentation. We actually started off as a Figma plugin right before MCP became a thing, and we very quickly pivoted to MCP. We put in evals to measure the code generation accuracy. We didn't know the changes that we were making, were they actually having a positive impact on our system or a negative impact on our system. And we didn't know how to talk to our leadership. We didn't know whether it's 60% accuracy or 90% accuracy. So because of these evals, we were able to take meaningful quarter-on-quarter goals so that we can improve our accuracy by X% every quarter. And we realized and acknowledged possible integrations with other vibe coding tools. We know that this may not be the final solution. There is a lot of evolution yet to happen. We want to integrate with tools like Replit and Lovable and what Sankit is going to speak about today. And we realize that that is only going to happen if there is some standard in place like MCP, or we have really, really good documentation that we can give to these tools so that they can leverage our design system. So if you want a takeaway from today's talk, it's going to be this. Well, not really. Well, kind of. But write high quality documentation so that the better the documentation is, the better the outcome for the AI is, whatever tool that you're using. Be willing to learn new things, step outside your comfort zone and experiment with new tools. And automate mundane stuff. If something used to take you 10 hours to do and now it takes only 1 hour, you have 9 hours left to do actual creative work or, watch TV and stuff. And surround yourself with amazing people who are smarter and passionate than you. That's what I've done at Razorpay. Everything that I spoke about today is a cumulative effort of this entire team. And they were not just trying to achieve goals, but actually create real magic. Some of them are here at ReactNexus today. So if you see them, go say hi. That's my time, folks. I hope I sparked some curiosity today. Happy to talk more about this offline. Thank you.